Well, howdy, y'all, and welcome to a awesome new episode. We have a great show in store for you. We're coming to you live from the Mile High City in Denver, Colorado. I'm your host, Willie Snyder with Nat King Code. I am joined by my partner in crime from Volt Online Academy, Mr. James Stallcup, creator of the High Voltage Live podcast and creator of the best online training program you can get. Feel free to check out any of the links you want. If you join our NEC Deathmatch, you can get all the links right to his learning management system. You could take some of the practice tests. They're free. None of the stuff costs anything. You could just go in there. He has free training programs. He has free stuff so you can see how good his system is. He's already incorporating all this stuff into 2023. And I'm just really excited for the future with your code change book coming out. And I think you said it was like 237 changes this cycle. And so that's cool. You could give me that extra 20 that I didn't get on the last cycle and I get squared up there. But it's really awesome to have you with us. And I really thank all the participation we had this week in Nat King Code Myth of the Week. And I really appreciate James putting together all the different topics. And, we had Senior on with the intrinsically safe. And it was really awesome. That was a really good lesson. So you guys can always go back, look at our old episodes and see what you missed. And as well, you can ring the bell, subscribe to the Volt Online Academy YouTube channel. And then you'll get notifications right when we go live and you'll never miss another episode. And I'm real excited that we put this together. And then we actually added, since we started doing this, we added 5 code changes for every show. That's an additional thing that we do. So I think that's James just trying to pay me back for the other code changes I didn't get last cycle, because I guess Colorado was short from the regular program on the code changes for 2020. So that's cool. That's cool that you're getting me back. I noticed there was something weird. I knew I started counting them. And then when I seen it was about 20 different from the last one, but no, it's really awesome what you're doing. And I'm really proud of all of the success we've had with NEC for Dummies. And that group is just growing fast. We're over 18,000 now. And it's really awesome. All the topics we have in there, we have like some just cutting edge, state of the art, like everything's up to the current code. And if you guys can ask questions or you can put posts from like 2017 code, that's fine. And I still have a 2017 book, and we'll still answer questions from whatever code cycle. We're just getting to where a lot of states are on 2020, and we still haven't heard the results of what the Standards Council vote is. So it's going to be interesting. Everyone's on kind of pins and needles to hear what happened, but it's going to be interesting to see how that moves forward.
It's coming soon. I've been checking periodically to see if anything's been loaded up on the NFPA side. It's not there yet, but one of the things, as an example, looking at 210.8F, if you actually go in and read the 2020 version on the TIA, this was supposed to be taken care of by 2023. And that was from the Standards Council telling them that. And we still got problems. And when this all come about, I told them we're going to have problems. And everything's coming to fruition now, and everybody's saying what I was saying at that time is true. And I said, whether you clarify it as an outlet or not, I really don't, I don't agree with it, but you're going to have a compatibility issue. And I got crucified. You don't know what you're talking about. You think you're smarter than everybody else. Guess what? The UL standard I told them was coming out. There's a compatibility issue. And
I actually have a buddy in the state of Colorado, and he's like, dude, he goes, when we're sending these inspectors out, we're not going to tell them like, okay, well, make sure that this unit gets on GFCI protection, and then make sure this one doesn't. He's like, dude, it's got to have consistency. It's either going to be all across the board or it's going to be not at all.
Yeah.
And they'll probably strike the whole thing down if they end up finding out there's going to be a compatibility issue to 2026, which we're pretty much thinking they're going to have to do.
I'm
We're,
looking forward to it.
we're,
I really want to see what the Standard Council has to say.
weren't we showing that the compatibility issue was listed by UL till 2024?
Yeah, even at 2024, you know, it was at 10 milliamps, and I said even by then they're only going to update that UL standard probably every 3-4 years. So you're going to have problems in the 2029. I said,
Right.
there's going to be a problem here regardless. And, you know, you remember, you saw the threads, they crucified me, said, you don't know what you're talking about, blah, blah, blah. And
Well,
here we are.
we both were just asking questions. We weren't saying anything, you know, like we weren't trying to stop them from selling GFCIs, you know, but
Nope.
I mean, it's the whole thing. Like, I agree with it on a dryer. I think that's a good change. But, you know, that's the thing, is you're protecting the dryer outlet. You're not protecting the dryer termination point.
No, you're not.
So,
And
you know,
and you'll remember I brought that up. I said, when they're talking about that in the outlet, that's where you're making it's a cord and plug connected. And that's why, you know, I gave the example. I said, if you're going to say everything at the end of the wiring method's an outlet, well, hell, you don't need the definition for a receptacle outlet or any of those, because you're saying there's an outlet there anyway. That doesn't make any sense to me.
yeah, lighting outlet is a good one. You
Yeah.
know?
Appliance outlets. I mean, just fire outlets, fire
Well,
alarm outlets. I
I
mean,
thought it was interesting because I looked up the expanded content and link. If you look up the expanded content, you go to nfpa.org and you go to the free content on link, and you look at the expanded content on 210.8f. It says where connection to an appliance outlet for AC equipment or HVAC equipment. Okay, well, where's the appliance outlet? It's just an invisible appliance outlet that it connects to. You know, I
that's what
mean,
I was saying the whole time.
it didn't make any sense.
You know, there's a lot of things that are taking place now within the industry and all that. And uh, I'm curious to sort of see some of the items and how it's going to go. You know, and there's been a lot of stuff that has changed in this cycle of NEC also, as far as calculations are concerned. And they went and renumbered some stuff again, which I just don't agree with. But there's a lot of stuff that has taken place that's going to have to be fully explained. And you know, usually we do anywhere from 150 to 200 changes every cycle. Every now and then you'll get a cycle there's a little more, but this is we didn't expect there to be as many changes in this cycle. And then as I was going through it, I was like, damn, man, there's a lot of changes there. And by the time I finished wrapping that up, you know, we're going to cover a full 237, and
Wow.
we've already edited 3 of the chapters. We're working on the rest, and they're finishing the illustrations to the later chapters, which of course the later chapters don't have as many changes as the first 4 chapters, as always. And
Right.
we're probably, when I get through 4 and 5, we're probably already covered 75-80% of all the changes, getting it ready. So
Well,
we're getting there.
as like a general thing, don't just most of the code guys that do those code change books, don't they just cover like maybe the top 100 as like a?
Yeah, they usually do 100, 150. You know, the only one that really did quite a bit more than that was IAI. And I heard through the grapevine, I don't know if it's true, but they're not going to be covering as many changes this time. And it's not going to be as detailed as their other publications they had on other editions. Our book is probably going to be the one that is fully covers everything like it always has. But one of the difference between ours and the others also is not only do we fully illustrate everything, we also have a table at the top and we correlate it with other NFPA standards. So like if I was let's say I was dealing with hazardous locations, we'll have up there NFPA 496, 497, and 499 for hazardous locations. And then we also tie in the API 500 and 505 standards.
Well, what I really liked about yours too was how you did like the purpose of change and the code making panel substantiations, and that to me was awesome when I learned it. I felt like I came out from it learning something.
Yeah, we always go through the substantiation, and one of the things that's going to change this cycle, and I just want people to understand this takes me a lot of time to do this. So it's not some small task what I'm doing, but for the online version, I'll come through and I'll have that it'll go over in voiceover for the new text and everything, what it says. And then I'll do the first substantiation and the second substantiation from the first revision and second revision, if there's one there. And then I'll do the correlation of all of that with an opinion and statement with the illustration. So you'll have 4 different versions there that walk you all the way through the whole process to the final end of our illustration and explaining what took place. And I've never, ever seen that in any course I've ever.
Yeah, and if you guys are following us on other platforms, like if you're on NEC for Dummies or you're over on the 2023 Code Ninjas, you can see James puts his videos up there as like an example, and the one I saw was just killer, dude. I don't want to even mention what reference it was.
I'll tell you this, and I don't know what's going to happen, but I was contacted by Bloomberg TV, and they were wanting to do in the education sector, and apparently they had seen my all my different stuff on different social media. Nice. And they literally told me they hadn't seen anything like what I'm doing.
Wow.
And he asked me, he said, we went in, we looked at a lot of different stuff. He said, can you actually work those calculations online? I said, not only can you do that, I said, if you're out in the field and you have different values, you can use that like a form and put the values in and calculate it so you remember how to do it. And he goes, wow, he goes, I'm gonna tell you what, he goes, this is impressive. And one of the things I've already told him I'm not going to do is show all the different ways and the step procedures I have to, because I have to go through like 7 procedures to get to be able to do that kind of stuff. And I use different software in order to create all of that. Well, I'm not going to go on anybody's show and show them how to do that.
Maybe
that's proprietary information.
Maybe you could just get like a video of it, like going really super fast, like in like time lapse speed or something.
They'll slow it down somehow. I'm not showing how to do it. And I will say this: we've got another thing. I'm not going to tell who it is or nothing, but we've got another thing we're working on right now. We were contacted by a very, very, very well-known company, and they're looking at wanting to sell the courses, and also they're wanting to use some of our illustrations for their products. And we're going to be in discussions on that. And when that comes out, that's going to be a very big deal. And I just sort of feel now at this point, all the last 3 years I've been doing all this, trying to get everything ready. It's now starting to show the complexity, but the use of ease and how you can use our online courses. And I think they're eventually going to be one of the most popular things in the electrical industry, because they're it doesn't matter if you're studying for a test, you're doing inspections, you're on the job designing something. It doesn't really matter. Let's say you're on the job and you're doing motor controls, and you have a motor there and you don't know how some of the leads are marked. You could actually go through our publication in the generator, transform, motor, compressor, and I'm going to have everything colored and showing you how to own those leads and everything, so you know how to mark the motor. And you don't get that
right there in the corner of our screen. It's part of our logo.
Yeah, stuff like that. And that's what I'm saying. we spent all these years doing it. And it's funny, take that logo, for instance. We did a podcast one night. This has been months ago.
Right.
And he goes, I'd like to do a high voltage logo. I said, okay, well, how do you want it to look? And I literally created that thing, in 30 minutes or something?
Yeah, we were sitting there talking, and I had the wedge motor in my head, and I'm all, oh no, that leads purple and that leads gray, and
said,
then
okay, let's put it in there.
I did it just from memory because I made up so many motors that day.
Yeah, but it's awesome being able to do stuff like that.
Yeah.
And that's one reason I sort of feel like the NEC for Dummies and all these groups we have are growing so well. And, it's not going to be long. We're going to come on here. We'll probably do a special episode on a Sunday when we hit 20K, which is probably not going to be far off in the future.
Yeah.
Probably another, 2 weeks, maybe.
2 weeks, yeah. At the rate we're going, yeah. And that's the thing, too. That's what's awesome about this, because we actually post my myth of the week. So if you guys want, you could actually go into our announcement section on NEC for Dummies, and in there is all the myths that we're covering. So I'll usually put the myth number, and I'll say, this is myth numbers. I think this one was like 66 or something. I don't remember, but it's in there. All those myths are in there. So you can look at them. You can read them. There's code substantiation in there. And then if we're wrong or something, I could always fix it, or we could always, like sometimes I'll write something wrong. I'll put like an and in there, and it's like something's wrong with that. And that's fine, because I'm just sitting there learning. I'm learning from the best here. I'm learning from the top people. 4 weeks in a row, our guests actually held up the Stall Cut booth.
Yeah.
And these are top engineers. These are top professionals. So it's pretty awesome that we could be up there like that.
There was a guy, he posted on one of our groups. He said, those that know use Stall Cut publications, those that don't use others. And I said, brother, I said, thank you for that comment. But, when you get into this and you start looking, one of the things we're really known for is the calculation portion, because we make it so easy. Mm-hmm. And the reason that is because we break everything step by step, and we add extra steps if we need to. And then we show you the sections, the tables, anything that pertains. So you don't have to take our word for it. And especially in the online course, because you can click those sections and look and see for yourself what we're telling you is true.
Yep, absolutely. Oh. All right. Well, I guess let's roll the myth of the week.
Myth of the week. Let's get it started.
It's time for Myth of the Week.
All right. That's a freaking awesome tune. I love it every time I hear it. So the Myth of the Week this week was pretty cool. This is stolen from a source called the EC&M magazine. But I really like that picture. And what I really liked about this is that a lot of people, I had this actually happen on one of the job sites where the inspector's like, that's got to be a in-use cover. And I'm like, why? He's like, well, your Christmas lights are going to be plugged in there, and it's going to need an in-use cover. And so I was like, okay, well, show me the code. So he goes and he pulls it up, and I think it was in, I can't remember exactly. I think it was 406.9, I believe. But it basically says that receptacles that's installed in a damp location only needs to be weatherproof when the cover's closed. Mm-hmm. So to me, I'm like, okay, well, that's telling me I could use one of these flip covers. And he was like, you know what? He goes, I was thinking that those flip covers were illegal now, that you can't use them anywhere. And I says, yeah, and then we started looking at it. He goes, you know what? He goes, yeah, that's fine. So what I ended up doing, these receptacles, they still had to be weather resistant, and they still had to be GFCI, but we could use those flip style covers. And this was on the patios of these multifamily dwelling units.
Mm-hmm.
So I was able to save the company thousands of dollars just by using these flip covers because it was a damp location.
Sure.
And the boss was thrilled. He's like, "Oh, we have to have in-use cover." I said, "For what? For wet location?" He goes, "Yeah, that's a wet location, isn't it?" And then, no, it's a damp location.
Mm-hmm.
So that's where these definitions are important. And it was really awesome. And the inspector was really cool. And I never argue with the inspector. I always agree with his substantiation of what the code language says. And if the code language doesn't say it, then it probably doesn't say it. I mean, a lot of these guys imply a lot of stuff in there and say, you know what, I'm saying that by being weatherproof, it has to have an in-use cover. Okay, well, show me in the code where it says that.
Sure.
And so it's really interesting. I challenge all of my viewers, all of my followers of Nat King Code to always have the inspector give you a code reference. I think Senior said that a couple weeks ago, where he's like, I gave him the code section and he did it, and that's what was awesome about it. And I told him, I was like, dude, I love the fact that you have an inspector, especially a great knowledgeable inspector such as Senior, that's gonna give him the code reference and say, all right, now I'll let you do it as long as you go open that door with that flame lit. And he's like, I ain't doing that.
Yeah, he's talking about that was that spray paint booth that guy had.
Yeah.
I remember that.
Yeah,
that's pretty good, because what you were saying, that led us right into definitions and talking about what is considered a dry dampened location. And when you start looking at that, as you were explaining, in a damp location, those are locations protected from the weather. And of course, it's not subject to what? Saturation. And that's what a damp location is. And when you get into a wet location, that's where you're going to have saturation with water, other liquids, or it's in direct contact with the earth. Yep. And that's what I like about this. I always found it interesting because my brother, he was installing some 4 plugs. And of course, he ran everything in the slab. And the guy told him, I forgot what cable he was pulling, but he said, you can't use that. That's a wet location. Frank goes, oh, okay. He goes, so are you telling me that 4 plug needs to be rated for a wet location? And the guy just sort of sat there for a second, and he goes, yeah. He goes, well, it says its installations underground are in concrete slabs in direct contact where. He goes, that's correct. He said, but if you're going to make me use that type of wiring method, then I have to have some type of enclosure for that 4 plug that's rated for a wet location, and it wasn't. Yep. So he ended up letting him use the wiring method. So he sort of twisted it on him.
Well, and this does kind of tie in with one of our myths that we did with the Romex in the damp location. Yeah. Because that's a code violation right there. And that's the thing that's funny. If you go into 314.15, it basically says that any wiring method that's installed in a damp or wet location needs to be listed for a damp or wet location. Sure. So, like if you're calling that a wet location, then all the wiring method and the enclosure itself have to be listed for a wet location.
That's right.
So we're going to do that next week, and I'll try to find something cool. If anybody has an idea of something that is just over the top funny, then hit me up and we'll throw it in for next week's Myth of the Week.
Sure. And so what I did, I started looking at that, and I said, okay, well, if you look here, and this is what I gave my brother at the time, I said, if you go over and you look at 300.5B, and then you also look at 300.9, but in his case, 300.5B, it tells you the interior of the enclosures or raceways installed underground shall be considered to be a wet location. Of course, those conductors have to be rated for that for 310.10C. And then if it's above grade and you have wet locations, then they tell you that the interior of those raceways shall be considered a wet location also. and you'll see it refers you to the conductors once again in 310.10C. And then
Right.
when you get over to 10C, you see the different type of conductors in 310.10B and C for dry and damp locations, and then also for wet locations.
Right.
And then once you get through that, then you go back over here to the enclosure and 314.15, and you'll see there it talks about in damp or wet locations, and it talks about all them boxes and everything. They have to be rated for what?
Wet location.
Wet location, or say listed for use in a wet location.
Right. Right.
And that's why I put this together, is because I wanted people to see what you get into here. And then there's an informational note number 1, which I took my brother to. When it talks about boxes and floors, it tells you to go look at 314.27B.
Right.
So that's why I went ahead and used some of these examples, and for people to be able to follow and see, exactly what the code says. And
Well, and what's so awesome is we have a bunch of apprentices in there, in here, and the thing that's nice is when you can go in and you can tell the inspector, like, hey, I think the code says something different than what you're trying to enforce. And a lot of times the inspectors will be like, you know what? I mean, you learn from, I learned from these first, second year apprentices all the time. I'm like, yeah, you know what? You got a good point. It doesn't say that.
Yeah.
So it's pretty cool to have
and what
that.
I tell, especially apprentices and stuff, to start learning, there are different types of enclosures. Because if you go over and look at table 110.28, you've got here for outdoor use. And
Dude,
then
did you put color in that? That's new, isn't it?
that's something I did for the new online courses.
Okay.
And I have
Cool.
everything, all my tables will be in color, and the
Dude,
color
that is looking slick, brother. That looks nice.
this color format is matching the format to the new illustrations we're doing.
Okay.
So
Cool.
all my boxes and my call outs and everything, that box around it, and my notes and stuff, they're in the blue, orange, or gray. And I finally decided on this color scheme after going through I probably went through about 20 different versions before I thought this one looked the best.
Dude, I'll tell you what, I really approve your lemon head at the Energize equipment thing. That's the best one.
Yeah.
The lemon head. You got an A+ for me on lemon head. You got the gear.
Well, I try to make everything, a certain way, and when we're doing the coloring and the illustrations and stuff, like I was just showing Dad today, I've now completed 7 chapters completely, and I was showing him all the new generators and stuff that we have, and I've got them done in a red color and all of this. And he was looking, he goes, man, that looks sharp. He goes, we may have to have one of our publications where you can buy them in color, because a lot of people are going to want that colored setup that I've done. And he's thinking about having one that's a cheaper version that's in the grayscale. But if you want a book in color, we'll actually have it available, but it's going to, it'll probably be double to triple the book. And the reason that is because it's based on what the printer charges us to do a colored page.
Okay.
And I'll just tell you, it's not cheap. So, but anyway, this sort of just ties in and lets them know they're different enclosures. And then it'll tell you over on the left-hand side of the table that it provides protection to a degree for the following environmental conditions that are there. And then you come across and it'll tell you your different type of conditions. Then it'll go across and tell you the enclosure type number, whether it's rated for that type of area.
Did we find, I can't remember if we, in our wet location one last time for enclosures, did we find something that was a little off on this as far as the 3R, with like the 3R and the rain tight?
What you're talking about is right in here. And we were talking about the different ways it was set up here. And here's your 3Rs and everything, and coming down based on the different type of of a enclosure, what it's rated for and how you can use it. So we said if you had something that was in temporary submersion or prolonged, you had to use a 6 or a 6P.
Okay, because a lot of people think the 3R just is good for everything.
No, it's not. And
Yeah.
if you look there, it's not good for sleet, windblown dust, hose down, corrosive agents, or temporary or prolonged submersion. And
Nice.
that's why this table's there. And that's why I tell apprentices, just don't automatically assume it's rated for a certain environmental condition. You need to look at this table.
All right. Well, the conclusion to the myth of the week is busted. You do not need an in-use cover for a damp location on the receptacle. The receptacle still has to be weather rated, and you still have to GFCI protect it, but you don't need an in-use cover.
Correct.
So
And
that's what I was trying to prove.
And that's what breaks it down. That's why I say look at the definitions, and then also be sure to understand, depending on the location, based on the sections that we were given there, whether or not the interior of that enclosure, the wiring method, and the box itself, how it has to be rated. And that proves everything right to that point.
Well, and what a good question that some people ask me. Is there any areas in Texas that the outdoors is considered a dry location?
That would be by amendment in that area. I don't know of any.
I agree.
I know it. There's some areas that are pretty dry, but they do get rain. So
yeah,
it
would be at
I've
minimal.
Never heard of that. I've never heard of that in any jurisdiction. So
okay, yeah, it was funny because somebody asked me, and I'm like, I don't know. I guess an AHJ could say, yeah, like we got like 2 drops of rain last year, so
the AHJ wouldn't do that. It would be an amendment that they have in that area. So.
Okay. All right. Well, no, awesome. Thanks for asking those questions in there, and I appreciate you guys bringing those in. And like I say, it was really awesome, all the participation we had on Myth of the Week. I had like so many good comments. I mean, dude, I'm hitting like 50,000 post reach on there, and it's like I'm just messing around and just, like not trying to tell anybody this is right, this is wrong. I'm just like, hey, what if this is, what an inspector said one time, and like, I find it funny because this one was really hilarious. So Mike Holt actually did a public input for 2011, I believe, where he said that the length of free conductor had to be 6 inches and it had to be unspliced.
That's not correct.
And they denied it.
Yeah, that's not correct.
They denied it. And so then it was really funny. I actually did it as one of my things. Hey, what's up, brother? Nice. Thanks for joining the stream, sir. So what was funny was I actually ran it as one of my Nat King code posts, and I put the exact language in there, and I added unspliced in there as if Mike's language passed. And everyone was like, true, because they're reading it right out of the book. And usually when people read something out of the code book, they read like the first 3 words and they're like, oh, that's true. They don't even read the whole thing. And and I had all these people saying true. And then I was like, oh, I got you, And they're like, what? And then I was like, it says unspliced. And then everyone's like, well, it has to be unspliced, doesn't it? And I'm like, no. And so then we started talking about it. And they're like, dude, it can be spliced 3 times as long as it's 6 inches long.
Sure can.
So now for 2023, I don't know if you could pull this up or not, but for 2023, I believe they actually mentioned that the 6 inches of free conductor needs to be, or can be spliced. It doesn't have to be unspliced. It can be spliced. So, and it was just funny how, Mike went and put that out there, and then they denied it in 2011. Here we are, 10 years later, and now they passed this basically the same exact language, but it says that it doesn't have to be unspliced because that's what creates those myths. And that's why I try to do this stuff is you have these public inputs going in and they're saying, oh, this should be unspliced. This should be unbroken. This conduit length should be unbroken. Why? Why is unbroken? Like, now I get it for, like, let's just say you have a piece of EMT. You go from your J box to your first piece of structure and your support is at within 5 feet. Now you're allowed to do that as long as that's unbroken. I get that. I get that language.
Well,
yeah, he does. Yeah, he does mention that.
the splice allowance, is he talking about?
No, he mentions that Mike mentions that the in the 2020 code changes series, he mentions how he actually did the public input for 2023, and now they actually do say that it can be unspliced. It doesn't have to. It can be spliced. It doesn't have to be unspliced.
Yeah.
So they didn't mention it in the language report. That's what I was saying. It's probably in one of your code changes for whatever that section is. I think it was. Where is
I'm
that?
sure we covered it. I've
It's
done
300,
so many
I think.
changes. I don't remember them all.
I think it's 300 something.
Yeah.
Is where that's at. 320 or 318 or somewhere in there.
I'll check it. I'm just now starting that at chapter 3, and I did those chapter 3 probably about 3 weeks ago, and I don't remember everything I've written since. I've written so many dang changes that,
right.
I mean, it's all brand new. It's hard to remember all 237 of them off the top of my head.
Dude, and like I say, I'm going to remember the 20 that I missed last cycle the most.
You blame that on the state of Colorado. It ain't nothing to do with me.
Dude, I will tell you what, if for some reason there ends up being a few of your illustrations that get leaked out to some different Facebook groups, I don't know how that happened. I was just borrowing them and, whatever. Like, they might get shared to some other places and it might be on like certain hot topic code changes.
We're going to have good publication this cycle. We're doing a lot of cool stuff to it, and I'm looking forward to it. And I think the online course is going to be fantastic once I get all the first and second revisions, everything put in it. And awesome. I've never seen it done before. So one thing I'm always doing is I'm always trying to kick it up a notch, do something nobody's ever done. And when I start doing that, I start realizing it takes me a lot more time, but that's okay. It'll be fun.
Awesome.
All right, let's roll topic of the week. What do you say?
As long as it's got a new song. Oh, I got you.
Uh-oh. Yeah.
Metal S.
Metal
AF.
I've got another one too. Don't worry for the changes. All right. Let's take a look at topic of the week and get into this because there's quite a bit here. All right. Now, one of the things that we set up in our publication when we start getting into this, because it's right after electrical theory, we start getting in and looking at the different types of circuits. And what we basically explain here and when we're looking at these types of circuits is we tell you for the current to flow in a conductor, basically is what we're telling you here. You have to have a difference of potential, and it must be maintained between the load and the source. And then when you're looking at an electrical circuit, this difference of potential is usually supplied by what? It's usually a battery, a generator, utility power of some sort. And then once you look at it based on that concept, both ends of the conductor must be connected to the terminals of the source, which we like to refer to as our electromotive force, basically.
Right.
And that's for the current to flow. Okay,
Right.
that's when you start getting into your type of circuits. And then we're
And
also,
so in this circuit, it's only flowing in one direction. Is that correct?
yes, and I'm gonna get into all that because I'm gonna show you a
Okay.
couple of things here.
All right.
Now, we tell you here with one end of the circuit connected to the positive terminal of the battery, like I'm looking at right there in the illustration. Okay. And then we tell you where the other end is connected to the negative terminal. Basically, what happens here is a circuit is formed with a load connected in the middle. And after that is there, this allows the circuit to connect and disconnect the supply power to the load, basically. Okay. Now, one thing I will point out, if you're looking at something like this, basically we'll tell you that this load that we're looking at, this could be something like an electric alarm, it could be a bell relay or any other type of electrical device that can be operated in this type of circuit. Okay. Now, when the circuit, we'll tell you here also, is when the switch is in the closed position, then we tell you here that the current from the battery flows from the load and back to the battery. Therefore, the circuit will only operate when there is a continuous path through which the current can flow from one terminal to the other. Now, if the switch is in the open position, of course, then the path is what? It's broken. And when
Yeah,
that happens, the current flow stops at that point.
and this is a key point too that you mentioned when we're doing like controls and stuff. You want to make sure you have normally open, normally closed. So, like in a
Right.
case where you have a light that turns on when something closes, then you want that light to turn on. That would be like a normally open when the contact closes, it turns the light on. Now you
Mhm.
want to do something where you do the opposite, where you want the light to turn on when the door is open. Now you put it on the opposite contacts and it does the exact opposite. And it's the same exact thing.
Sure.
It's just the opposite as the circuit. So the control voltage is still the same. The contacts are still the same. You just reverse it from normally open, normally closed, and it reverses the operation of what you want it to do.
Sure. And when you look at this, and we show you over on the left-hand side, we're talking about open circuits here. But basically, when you look at this, when an electrician really starts to have a problem is when he encounters where there's an open circuit, short circuit, or ground fault has been created. Now, when I look at that and I start working on these type of systems and I'm going to perform troubleshooting of these type of circuits, or it could be a defect in that case if it's an open circuit. The journeyman himself or any electrician that's going to work on it, they need to be really versed and trained on the operation and characteristics of an AC and DC circuit. I mean, that just goes without saying. And then when I look at the open circuit, basically, a lot of people, especially apprentices that are watching this is one of the most common problems that they're going to encounter is an open circuit. And when they're troubleshooting this on electrical systems, basically the only thing that an open circuit is, what it basically means is this, is that there's a break somewhere in the circuit and you have no current flow. That's basically what it gets into.
Yeah.
Now,
well, and that's another thing too that I always tell everyone is there is no circuit that you can't test in an electrically safe work condition that you could test the same way energized. So you can test all these circuits for continuity, for you could find where your continuity is broken, all this stuff. You can do that in electrically safe work condition. It does not have to be energized all the time. There's some cases where it does, but I'm not trying to say there's not, it's a 0% thing. What I'm saying, okay, so 99.9% of the time when we're doing DC control circuits, we're going to be using a normally closed. So it's a normally closed. You could test it with your meter. You could say, okay, cool. I have continuity. I have the resistance going through that circuit. And there is no current applied to that circuit yet.
Mhm.
So you can actually say that that circuit is going to work from a DC standpoint. You
Sure.
can look at your meter, you could read it, and you could say all these functions, there's no ground, none of the conductors are grounded. The conductors show the correct resistance, and the conductors, there's basically, once you apply voltage, that's going to function correctly from a DC standpoint.
Sure. And how many times do you see where you have an open circuit and you find it over in a junction box? It's come loose at a Scotch lock or something. And
Well, you don't really want to go there with me, but the like when you're doing industrial, you have a lot of different scenarios. But I mean, it's like I've had times in a DC circuit where we're using non-metallic boxes, non-metallic devices,
sure.
and it got filled up with water through condensation.
Yep.
This is another thing people say they don't know how it happens. But what you have is you have a temperature difference from one side of the enclosure to the other side of the enclosure.
Mhm.
You have like an oven that's really hot, and you have a AC unit running upstairs, and you have that 20-degree temperature difference, which creates a dew point, and then that flows water into your device. Well, now what happens is you have two separate notification. You have two separate notification circuits. One of them is a speaker. One of them is a strobe, so a visual and an audio. And then what happens is when that water goes in there, it doesn't cause a ground fault because it's non-metallic devices. What it does is it shorts the speaker circuit to the strobe circuit. So
Sure.
now your panel gets a trouble saying that your speaker circuit's in trouble. And then when you go measure the voltage at the panel, when you measure the resistance at the panel, it's showing 4.7K, which is the strobe resistance. So you're like, okay, well, that's what's put it in trouble. And then once you get the water out there, then your speaker circuit goes back to the 47K.
Mhm.
And so that kind of stuff, when you go in there, you start realizing from a troubleshooting standpoint, oh, that device got water in it again. And there was top techs that were coming out there trying to troubleshoot this stuff. And they're like, dude, what's going on? And I
Mhm.
was like, oh, it's just watering device. Yeah, I'll send my apprentice down there and get the water out. And so it's so funny. He's like, how do you know that? And like, dude, one of them, we pulled the strobe down. I mean, it was like like off Survivor. Like you could live off the water that was in the top of that device. Like, I mean, it was crazy. Like it was a full bowl of dog water, like I'm like, wow. I mean, it got full. So, some of that stuff you have to, take with, like James is telling you, when you're going to troubleshooting this stuff, you have to know what this circuit's doing, what its purpose is, and how it is supposed to function. And then
Sure.
that makes you better.
Sure it does. And then
We got a good comment just came in. Yeah, condensation can occur in electrical testing.
oh, yeah, sure it can.
Oh yeah.
Oh yeah.
Yeah, I've seen that.
Not going to disagree with that. I actually had that
Yeah.
happen before.
Yeah, I've had times where I pulled switches out of free, like walk-in coolers and stuff, and just water just pouring out while the thing's live.
Mhm.
And you're like, okay, this is not electrically safe work condition.
That's true. And another thing that you're going to run into when you're dealing with this is you can run into short circuits. And when you look
Yeah.
at a short circuit, I know a lot of people know what this is, but just for new apprentices, when does that type of condition exist? Well, that exists where you have an accidental contact between the conductors that permits the current to return to the power supply source through what? A low resistance path, right? And that usually occurs between what? Two insulated conductors, such as from your ungrounded phase conductor to a common or something like your grounded neutral conductor. That's
Right.
basically what a short circuit is. And then,
Yeah, and that's a good point. What I ran into before, and I thought this was really funny. I was tasked with taking a megger and going and measuring out a whole bunch of stuff. Do you know what reading you'd have in a short circuit?
No, I've never measured it, to be honest.
0.
I would think it's 0 because it's open. So,
Yeah, it's not
but
open.
I've
It's
never megged it. I just knew it was a
it's
short
basically
circuit.
both leads touching together.
You actually went in and megged it, huh? I've never done that. So
Yeah, yeah. So that's what we're looking for when we're going and measuring out these cables. If you have one that measures 0, they're touching.
yeah,
So
that,
that was a
that
good one.
that's pretty good. I've never actually megged one. Anytime
Yeah,
I had a short circuit ground fault, the breaker trips, and I just go figure out what caused the problem. I just
yeah.
I never measured it. I never even thought about it, to be
No,
honest.
we did another one that everyone will learn from. I learned from it just like last week. So when you have a ground fault on your system, you go take your meter and you take, like in this case it was like, say the black, which is the negative,
Hmm.
was faulted to ground. So we had 1 ohm. We had 1 ohm resistance. So that means we were relatively close to the ground fault.
Oh,
So
okay.
then we went to like 2 boxes down. Then it went to 0.03 ohms. So we knew it was just 1 box away. So the lower your ohms, the closer you are to your ground fault.
Oh,
So I thought that was a good lesson too.
yeah. Huh. So y'all just went from box to box, and then it lowered till you got down to 0.
Yeah, and then I went to the next one, and that's where it was.
Oh,
Once I took that next device out, it cleared.
hmm.
So that's how we found it, and it's a good lesson to learn.
Yeah, that is a good lesson because I've never done that before.
Yeah.
Uh, Usually,
A lot of these guys will learn that you never stop learning in the trade. I mean, I've got 27 years, and I'm out there every day, just like learning constantly. Like I'm just a sponge, trying to learn everything I possibly can. Just constantly like, what can I learn on this? What can I learn on that? I mean, I basically go up to the GC. I'm like, hey, isn't your job to do this? Oh, well, yeah. Well, then you should do it. Whatever. But it's funny. I give the GC so much crap. Like I'm surprised that they haven't like ripped me apart yet on some things, but the one we're out is we're on Union. We have a Union general contractor, and I go up to him. I says, "Hey, is it the Union for skilled labor?" I was just giving him a hard time.
that'll make them mad. You say that.
Yes, yes.
Yeah, usually when I was doing it, I just sort of track it back till I found it, but I never measured it.
Yeah,
And I'd never had a problem finding it. That's actually pretty interesting because I've never
yeah,
done that before.
yeah,
But when you look at a ground fault, basically, what is that? That's just your ungrounded phase conductor making accidental contact with what? A metal box, a metal raceway, something that's basically metal, right?
yeah,
So that sort of wraps up letting them know what the ground faults and stuff are. Now,
yeah,
when you get over here and you start, and this sort of tying everything in, if you notice the illustration itself, the way that we set these up, they're the same, but we keep adding to the illustration as we go.
yeah.
And
I think it's looking awesome, dude. I mean,
well,
you're just constantly improving.
wait till you see them in color. They look way better than this. But what we try to do is take you through the step procedures of what you would see in your circuit, and then from there trying to figure out how to troubleshoot it properly. And
Right.
and you'll notice we tell you there we got a circuit in trouble there due to what? Short circuits, ground faults, or an overload. When I see those 3 terms, it reminds me of the story Dad told one time, and he was going to Trimble Tech
Mm.
and going through basic electrical theory on circuitry and stuff like that. And he said the instructor was having trouble sort of explaining what the difference was between a short circuit, ground fault, or overload. And he said they had this kid up front just thought he was smarter than everybody. And he told the instructor, he said, he goes, I don't think you know what you're talking about. And he said the instructor didn't even miss a beat. He walked over and they had some reels of wire there, and he took out his strippers, cut it, and he went over, told the kid, he said, hold on the end of that wire. And he took his lighter and lit the other end. He said about 5 seconds went by. He let go of that conductor. He goes, now see there, class? He said, that's an overload. You're overloading your conductor. It heats up too hot. He said, then he reached across there, slapped the kid upside the head. He said, no, that's a short circuit ground fault.
Oh wow, we had our listener like right on it, man. Oh, that is hilarious.
Yeah, a
Oh,
lot of
man.
people had been in Dad's classes might have heard that thing, but he told that, I was like, that's pretty damn funny. So, but
That's funny.
when you look at a fuse, for instance, and it's part of the circuit, that fuse is composed of a metal or alloy that will have a low melting point, basically, is what a fuse is. And if the current or circuit becomes too great for that fuse, then what's going to happen? That fuse is going to melt and it's going to open the circuit.
Right.
Okay, that's basically how a fuse works. Now, you'll notice up there in the illustration, this is a rule of thumb for everybody that's watching this to understand. But a fuse normally holds 5 times the rating based on the type fuse. That's normally what a fuse holds. Okay. So when you look at that and you're looking at that fuse, and let's say in the illustration there, I got a 20 amp fuse and I take that at 5 times, that's going to give me 100 amps.
Right.
Okay. And the reason we put that in there, because we want people to sort of understand that it's set at 500%. And therefore that lets us know if I have a fuse there and I get a ground fault that's of 250 amps there, that fuse is going to clear what? Quickly, rapidly.
Yeah.
It's going to clear. So we try to make sure that people understand that 250 amps generated by that fault, which could be a short circuit or ground fault, that's why you have a fuse there, and that's the melting point. It's going to clear and open that circuit.
Right. And like, so the higher amps, the faster the clearing time, right?
Sure. And that's why we like to sort of show this as you're breaking it down. Now watch this. As you come in the next one, you've got your circuit breaker here. Now, a circuit breaker, when you set this up, a circuit breaker is usually going to clear based on its frame size. It's going to hold 3 times its rating. Okay. So if you look here, if I got the same thing, 3 times its rating, 60 amps. Well, if I got 250 amps generated again, naturally, what's that going to do? That's going to clear that overcurrent protection device, and it's going to open, isn't it?
Yeah, and that makes sense why you can't use the up, over, and down method with the fuse ahead of a circuit breaker, because
sure,
you're not selectively coordinated correctly.
Correct, and that's why we show this, because this stuff we're showing you, these percentages 3 times and 5 times. That goes back when my dad was doing electrical work, and how these guys used to go out there and
Dude, they were doing electrical work in Jesus's time. No, I'm just kidding.
I'm gonna tell him I'm telling him you said that.
I'm gonna get smacked. You're telling pops on me.
Now, basically, this is just like a typical series circuit, and anybody that's worked on Christmas lights, a light goes out, know they're in series, and you got to find where it is upstream that caused those lights to go out. And you go through each one of them and checking the fuse. Could be the fuse up front, or it could be where you got those little copper strands of wire come out, one broke off or something that's breaking the continuity. So that's what a series circuit is.
Right.
And then you get into looking at a parallel circuit. And when I deal with a parallel circuit, this is where there are 2 or more paths to travel, right? That's basically what a parallel circuit is. You got more than one path. And basically what that means is if the path through one of the loads is accidentally broken, then what's going to happen? The other loads are going to what? They're going to operate. That's what a parallel circuit is. Okay. Right. So you got 2 different paths, where a series, it's only one path, right?
Oh yeah.
And I think that's important, because a lot of apprentices don't understand that, right. And you explain a series is one path, parallel is 2 or more paths. There's a reason we have them set up that way.
Right.
Okay. Now, the next thing you look at is where you deal with a series parallel path. And this is where you have a combination circuit. And basically what it means is that you're going to have some of the loads connected in series, and then some of the others are going to be connected in what? Parallel.
Yep.
Now, when you get into this, now you got to start understanding how to do the calculations based for these different type of circuits.
Yeah.
And that's where we come in and we start breaking this down. So we're going to take a look here, and we're going to look at doing a calculation in series here. And one of the things that I will point out is you're going to see here, we got a power source of 240 volts. You'll see a load at 200 ohms resistance, and each one of those elements are rated at what? 50.
Okay.
Okay. And then the resistance of the power source is 0.1 ohm. All right.
Right.
So we're sort of tying all this in, and you need to know these values when you're performing this calculation. Now, what you're going to notice when you're doing a series, all you're going to do is looking in that circuit, you're going to add all the resistances together. So our first resistance we have there is 9 ohms. The second is 8. The third is 3. All I'm going to do is add those up. That's going to give me a total resistance of 20 ohms, and I'm going to divide that into 120 volts, and that's going to give me 6 amps. Now, I want you to notice when we did this before, we did Ohm's law, like, I don't know, it's been a couple of months ago, I think.
Yeah.
But we did Ohm's law.
No, I liked how you did that because you did the double formula. Like you did it how all the chart goes into one.
Right.
Which I thought was really cool because I never seen that before. That was the first time I ever saw that.
Yeah. And what we're doing here is the same principle. We're showing you we don't care what the resistance are. You just add them all up together in a series circuit. And then if you've got a 120 volt system, or 240, 120, we'll say, you divide the 20 ohms into the voltage, just like you do a normal Ohm's law.
Nice.
And before we were just giving you the values. What we're doing now, we're showing you how these values are determined to get to that point.
Nice.
Okay.
Ah, that's pretty amazing, dude. Right on. Dude, I'm telling you, it's easy when you put the numbers like that.
Yeah. Well, I've seen a lot of publications out there, and I haven't seen anybody that goes into the detail that we go into to show you how all this interacts with each other. And how you determine to do those resistances. It's like last week we did, and anybody watching this didn't watch it, I highly recommend you watch last week on AC Circuits, because we go through and show you what is really the difference. Even though it deals with the resistance, what's the difference between the impedance and resistance? And what it comes down to, one of them is based on capacitance, and the other is based on what?
Reactance.
And that's what we go in and we teach about when we're looking at all these different type of circuits and how it affects and applies to your Ohm law and pi formula calculations.
And I did win the award last week for stupidest question. So any of the listeners want to challenge me for stupidest question, you're welcome to jump in, ask stupidest question. I'm going to just keep winning the award every week. So
no worries. Now, you're going to notice here, we got a 120 volt power source, and then you're going to notice our resistance there. And we're going to show 24 ohms across circuit 1 and circuit 2, 6R, 8R, and 12R. Okay. Now, here's how you set the calculation up for it. You come in, you got your 30, 30, 60. Okay.
So this is a parallel, right?
Yes.
Okay.
And you'll see by the way it's actually
is this a series combination?
Yeah, it's a combination that we're working on here.
Okay.
And we're going to do
I just saw that parallel setup and I wasn't following, sorry.
Now, if you look here, we're showing you the different type of calculations. And if you look, and we do this on purpose because we want people to understand, right in the center of the illustration up top, you'll see formula requirements, and we're showing you how to get the total resistance. And actually, this one is just for parallel. It says calculation series, but we're just doing a parallel circuit here. Okay.
Okay.
Now, you'll notice in order to do that, you're going to have one, and then it's going to be divided by those other three resistances. Once you get that total, then you'll take that total, divide it into the voltage, and that'll give you the amperage for the circuit. Now,
Right.
now what I want to point out here, right there in step 3, you'll see 336. I've got to extend that calculation a little bit because it wouldn't let me put in the value 30, 30, 60. So it should be 30, 30, 60 there for my resistances. Now,
Okay.
what's going to happen is in the parallel circuit, you're going to take the largest resistance that's there in that circuit, what you're going to see is 60 ohms. So when I go down here below, I'm going to take all of those 60s down there, and then you look at the resistance that's up above. Now, what happens is that 30 is divided into 1. Basically, what that's telling me, to get to that 60, I had to have 2 resistances there. So 30 plus 30 is 60. So that'll give me a total of 5. Then I'm going to take that 5 divided in 60, and that's going to give me a total of 12 ohms. Then I'm going to take that 12 ohms divided into that 120 volts, and that's going to give you a current of 10 amps.
Right.
Okay. So that's why it's important to always look at our formula requirements there so you can understand what we're doing. And if you look in step 3, you'll notice right below where I would have 30, 30, 60, below it, I have 60, 60, 60. The reason is because that was the largest resistance. And then taking that 30 and doing 2 resistance, that's what gave me the 60. Then you add those total resistances up top, which is 5. That divides into the largest, which is the 60.
Yeah, and one thing I want to tell, like, all our apprentice listeners out there, that you can always take, like, say somebody gives you a formula question and you're kind of unsure about one of your steps, you can always go and take the answer and put it in there and kind of reverse engineer the whole thing. And then you kind of make it make sense. So that's why James does this whole layout like this. So you get that visual to where you see that triangle in there. And then what you're trying to do is anytime we're doing these mathematical equations, you have 3 sides to a triangle. And all you have to know is one side to that triangle. So you take the side that's unknown and the side that's known, you can find the other unknown.
That's right.
So it's James always puts this as really easy math in here, and I'm just trying to kind of clarify it for all the people that are watching, that this is how easy the math that he does in here is. He gives you all 3 sides of the triangle in this equation here.
Sure.
And all you need to know is all you need to know is 2 of the 3 sides.
Sure. And
doesn't matter which side.
That's why I did the AC first, because we actually go through and talk about the hypotenuse of that triangle and everything and how you do it.
Mm-hmm.
All right.
I agree.
Now, I'm just going to move right on to this one because we're going to get into showing this calculation here. And this is, if you'll notice up top, I've got the series, and then in between here, I've got the parallel portion. So this is a series parallel circuit here. And you'll notice for resistance 1, we got 10 ohms, resistance 2 is 8 ohms, and then 3, 4, and 5, we got 36 and 12 for the parallel portion with a 120 volt power source like we had before. Now, when I look at doing this calculation, you're going to see, look at my formula requirements up here in the middle. We show you how to do it for a series, and then we show you how to do it for a parallel. Now, what I want to point out here is we will get to RT, but if you're doing it for the total and it's a series parallel, we're going to use RS for series and RP for the parallel circuit. Now, as I look at this and I do the series, okay, just like we did a while ago, we took all the resistance and we just add them together, right?
Oh, yeah.
Okay, so that's 8 ohms. Now, as I look at the resistance here for the parallel circuit, I'm going to do the same thing. I'm going to get 2, 4, and 8. Then I'm going to go across, and you're going to take the largest one, which is 8. Okay. Now let's look at this. If I want to get to the largest, which is 8 ohms, I'm going to take 2 times 4 equals 8. And then I'm going to take 1 times 8 equals 8. Okay.
Right. Okay.
So you're going to go across, and then you're going to have your circuits there. So you got 8 ohms, and I take the 4, the 2, and the 1. And then that'll give me a total of 7. I'll divide that into the 8 ohms, and that's going to give me 1.1428. Add those all up together, and that'll give you 9.1428 ohms. And then you take that and divide that into your 120 volts. And that would give you your amperage for the circuit.
Okay.
So now what I want to point out here is, if anybody watching this, I did not change any of my calculations or anything. I performed the same calculation for a series circuit and a parallel circuit here. But the only thing I did is, once I did the calculation, I just added the 2 values up to get my total resistance.
Right. Okay. I got you.
And that's why I like to show that, because a lot of people don't really understand how that calculation is performed. And then, of course, the other thing that you'll look at is, in the circuit, you're going to deal a lot of times with static electricity. Okay. Now, I can tell you, I've dealt with a lot of different static electricities, and this is, we even make mention of this in the 70 document. And the reason we do that is because you have certain systems that you get static electricity built on the system, but they take it away from that area and they don't even ground the system or anything. Well, why do they do that? Because they know if there's an arc or spark that happens there, then you're going to have more problems. So they're trying to get rid of the static that's on that system.
Right.
So when I look at static electricity, basically, what does that mean? It means it's stationary or it's at rest. That's what static electricity is. But however, when you look at that, the electric charges, they're not at rest. You see what I'm saying?
Okay, I got you. I see it now.
And that's
Wow.
why we wanted to bring that up so people understand. So when I look at that as an example, you can look at static electric charges, and you can produce those just by rubbing various dissimilar substances together. And due to the nature of that charge that is produced, that takes and determines the types of substances you use that cause that different type of charge on those dissimilar
Properties
probably substances. We'll say substances.
Okay.
The dissimilar substances you're using.
Okay. Gotcha.
Now, as an example, you can take up here, you say you got a metal insulated sphere and it's charged negatively as it's shown. Basically, what is that doing? That's driving the positive charged electrons to where? The end of the rod.
Okay. I got you.
And that's what that's there for, is to sort of let you know that these balls, even when they do, eventually they're going to turn back to where? Their regular position, aren't they?
Yep. Absolutely.
Okay. But that's that charging is caused by what? Induction. And you look up there, we tell you at the very top.
I was gonna say inductance, but I knew that was gonna be wrong.
Yeah. And that's why we like to show this, so you understand what static electricity is. Now, once you do that, then you're going to get into what? You start talking about what is charging conductors. Okay. And these are principles of electricity that I think is very important for the apprentices to know. Now, when you take a non-conductor, for instance, basically non-conductive, and we just said that's like where you're rubbing dissimilar substances or materials together. But basically, when that happens, the charge still remains at the point where the friction occurred, didn't it?
Right.
Okay. And the reason that is because the electrons cannot move through the material. However, I'm just going back to what we were talking about on static. Now, as I look at the charging conductors, once a conductor is charged, what happens here? The electrons can move through the conductor. You see what I'm saying?
Okay, gotcha. All right.
And therefore, since that's the case, what do we have to do? We have to insulate from the other conductors, or that charge is going to be lost.
Okay.
And that's basically what we're getting into. And of course, when you look at electrical charge that's produced in a conductor, it's produced again by what? Induction.
Hey, I just had news from Seth Peterson, right?
Yeah.
His apprentice just passed the master exam. So congratulations, Seth. That's awesome, dude.
How did the apprentice pass the master's?
Well, he apparently took the master test. So, like in Colorado, what's so cool about Colorado? So you can go when you sign up to take the JDub. They ask you if you want to take the JDub or you want to take the master. And so he took the master and passed it. So,
oh wow!
Congratulations, Assess Apprentice. Yeah. That's pretty awesome, man.
That's awesome. Yeah, because in Texas, you have to be a journeyman for, I don't know what it is now. It used to be 2 years before you could even take the masters.
Yeah, they changed it, and I think, don't quote me on this. I know that Colorado is kind of heavy on the union a little bit, and I think maybe that there's no such thing as like a union master. I don't know. That's what I've been told. I could be wrong on what they said, but that's what I've been told. There's no such thing as a union master.
Okay.
And so maybe they were like, yeah, you can take the journeyman or a master. I think if you want to run guys, you go get the JDub. And then if you want to be just run work, then you get the master, and that's when you go out on your own. And so, no, congratulations. I think that's awesome, Seth. Great news, brother.
Yeah. All right. Now, once you understand the charging conductors, then what's the next thing that you're going to deal with? You're going to deal with the electric current flow, right? So the next one should be electric current flow. Yeah. So here's your electric current flow, and we're just giving you an example of pulling and attracting with a magnet and how you have it, the rotor and stuff, how it turns. Basically, you have a repulsion and attraction, don't you?
Oh, yeah.
And that's what you get into. So basically, what is electric current defined as? That's the flow of electrons through what? A conductor. That's all it is. So those free electrons of that conducting material, they'll take and move from atom to atom as a result of attraction of unlike charges and the repulsion of what? Like charges. You know, it's like I always said, and you know, I've heard this before, but the government takes and limits the size of magnets. And I think the reason that is because if you put big enough magnets and you just get it started, I think you could produce unlimited energy from now on.
Yeah.
That's my opinion.
I agree. The thing that I've tried it before, from like solar aspect, basically you can't get something from nothing.
Sure.
Eventually, basically you have to have an electron to push an electron, and at some point you'll reach a 0 point.
Sure.
I mean, it does work. It does work, and you can go a very long time. But at some point, you reach a 0 point. You reach the end of battery life. You reach end of solar panel life. You reach end of life of everything.
Sure, you do.
And so I did it personally. I did it. I ran a whole bunch of lights off solar, and I did it the way I thought it would work, and it did work, and everything worked, but it just got to a point where everything died, you know, and I kind of thought in my head, oh, it's going to last forever, you know.
Well, that's why you got a backup that connects to it, and then you replace them components right there and get it back up the next time.
Yeah, I built a really nice system, and I thought, oh, man, this is going to last for like 20 years. It lasted for like 5 years or 4 years or whatever. Mm-hmm. But the whole thing is, like, I saw it taught me the benefits. You know, I saw that, you know what? I could make one that lasts for 4 years, and then I can make another one that just replaces it and lasts for 4 years, and I can replace that one with another one that lasts for 4 years, and they could just keep replacing themselves. But it's really hard for humans to think that way. We want to think like, I want to put it together, I want to turn it on, and I want to just walk away and never look at it again.
Doesn't work that way. Got to maintain.
Yep. And so that's a NFPA 70C. That's my NFPA 70C for the night, my 70C reference. And I think it's a good thing to have it in the standard because, a lot of these big corporations are like, just run it till it dies.
Sure.
And so we'll sit there and see some stuff. And we're like, hey, we got to do scheduled maintenance on this thing.
Sure.
And what's really cool is that now NFPA 70 recognizes that as a standard. And I think it's funny. You go to some of these plant guys, like these big plant guys, like they're pushing rods or whatever, they're doing whatever they're doing. And you're like, dude, that's a code violation. They're like, no, it's not. I got 20 more foot of rod to push tonight. Okay, well, I'm just telling you, it's a code violation. You know what? You come back with that code violation and all freaking shut down. I'm like, okay, cool. Come back with the code violation. All right, Snyder. You got an hour. So I better have my plan down pat of how I'm going to shut that rig down, how I'm going to fix that equipment, and how I'm going to put it back up in service in 1 hour.
Yep.
If I don't have that, get the hell out of my freaking quarters. Get the hell out of here. You don't even belong in here. And it's like, I come in now, I have a freaking plan. I'm like, this is what we need to do. Da, 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 da. It'll take 45 minutes. Here's what we have to do. Da, 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 da. They're like, okay, cool. Boom, shut it down. They go take a break. I say, boom, boom, boom. And all right, sir, have a good day. See you later. And then they go, wow, that was scheduled maintenance? And the whole thing was, the reason they don't like scheduled maintenance is because none of the maintenance dudes ever have a plan.
That's right.
They just want to do it fly by night. They just want to just go up, see their pants, and just go, oh, yeah, put that guy over there. Nobody knows what's going on. So
I'm with you.
It's one of those things that I like 70C being in there because that does go hand in hand with what we do.
Oh, sure it does.
We have to know all these standards and know how they apply to each other and make them all work together.
And that's why I bring up certain standards as I'm teaching this, so you understand why we mention certain things and certain standards, because this is a direct effect to the operation of the circuit itself.
Yep. So, are you 100% done with the topic of the week?
No.
Okay, keep going. Keep going.
All right. Now, once you get through the electric current flow, then naturally you're looking at what the potential difference and also the electromotive force of the circuit and how that operates. Now, we give a good example here as you're looking at sort of like a water tank. And the reason that we tell you that, if you have two tanks as an example, and they're at different water levels, okay, like we see there, and they're connected by a piping system, and you've got your on and off valve that's right there. What happens is the water flows from the tank with a higher level to the other tank when the valve is in the open position, of course. And of course, that means the difference in the water pressure is due to what? The highest water level that's in the other tank. The same thing happens in the circuit and how you produce electromotive force.
So the water tank thing, that would be indicated as the voltage in the tanks?
Sure. When you look at it in electrical circuit, as we're looking in reference to the tank of water that's there, you have a large number of electrons at one point, and that will cause a current to flow from one point where there's a smaller number of electrons. In order for that to do so, what that means is 2 points must be connected by what? a conductor. In other words, what we're telling you is that the electron level is higher at one point than another point, and there's a difference of potential between those points.
Right.
That's what you're basically getting into. And if you look at that tank of water, you have two different points with a different of potential. Well, naturally, as you let out from tank one, it's going to flow to tank two because you have a greater difference of potential there. The same thing operates in a circuit. And the reason I like to point this type of illustration out, because a lot of people think, it's two different things. Well, no, it's actually the same because it's operating the same. And that's where we get in talking about the difference in electrons, protons, neutrons, and all of that. And how do you take and produce an electromotive force?
Well, and this is a good example too, because like if you're standing at that point of differential and you're not in an electrically safe work condition, that potential of electrons is going to want to go through your body before it's going to want to get to that other side.
That's right, because you're a difference of potential. That's what I always tell people. And this break, now I'm not going to do any more after this, but the rest of it just gets in and showing it, dealing with your Ohm's law and stuff. But this is a great example to show you how the system works and what is your different type of problems you can run into a circuit, and then understanding what the difference is between a series parallel or series parallel circuit and how to calculate those to determine to get to this point where you got the electromotive force and how that is calculated in. So I think this is a really good presentation for the apprentices to understand how a DC circuit actually functions.
Dude, I think we got a bunch of way smarter. So all the dudes that work on my crew, they're all ninjas. We're all ninja crew. Like everyone, that works on my crew, we might break a little bit of rules sometimes, but when it comes down to getting the job done, we get the job done. Right. Whatever it takes. Like if we have to work a few extra hours or work through break or whatever we have to do, we're ninja crew.
Get it done.
We're SEAL Team Ninja. Like that's what we do. Like we have to. We're the guys that just are sucking it up for the 1%. Whatever we have to do. But the thing that's really awesome, I'm really excited about this. I've been bringing you guys a bunch of tour reviews, and I like to
wait. We got to do the 5 changes first.
Oh, well, no, I'm not actually announcing the tour review.
Oh, okay.
I'm just giving everyone a preview. Just to wait. So I'm doing a tour review that is actually, it's pretty negative. It's like my most negative tour review. Everyone always challenged me. They said I couldn't do a negative tour review. I really can't. It's impossible for me. Like I'm still like, well, it benefit you if you're in a tight ceiling, So, like, just don't let me go positive on our tool of the week review. But we're gonna do our 5 changes. I really appreciate you, James, bringing in the 5 changes. I just wanted to give everyone stay tuned. The tool review is awesome. I saved it up. Everyone loves this one. This is a favorite tour review of all time.
All right. Let's do the 5 changes real quick.
All right.
How do you like that?
I like it. Music, A+, everyone. A+.
All right. This week, we're still going to be in Article 250. And first one we're going to look at is 250.92b. And
I like
basically what they did here is make some clarifications here. And basically what it gets down to is they're telling you by an applicable method in 250.8a. I don't really consider that much of a change, but it's just sort of clarifying that it has to be one of those methods. But the Pren 2 is, because they literally are coming in now telling you to sort of match up that everything has to be made up wrench tight using threaded couplings, threaded entries, or listed threaded hubs on enclosures. Basically, what they're telling you here is the methods of bonding at that service. This is talking about stuff that's what? Threaded. Okay.
Yeah,
So,
and this is a good point because I need a I have a flow chart of all the things that need to be bonding bushings. And I need to post it in our announcement. I'm going to do that. That's one thing I've been wanting to do. I'm going to post it up in there, but it's a
sure.
really cool thing. It's a flow chart of everything that needs to have bonding bushings.
I think that'd be good. And I think that's a good change. Then they did another one in 259.4 where they're talking about the communication systems. And what they added here was a whole new sentence at the bottom. And they tell you that the bus bar shall be connected, of course, to where? The grounding electrode system by a conductor that is larger than the following. And then they tell you where you can go to pick this information up. And how many times have you heard me say this? The first one, the largest grounding electrode conductor that is connected to the bus bar. You remember when they were talking about the jumper coming over, and I said you had a bar there, and I said if I come up with a number 4, number 2, it could be a 1 off, whatever the largest was connecting to that is what you had to connect back up to the service equipment.
Oh yeah.
And this is sort of tying this in. And I think this is very important because they're letting you know when you're bonding that communication system in and you've got a terminal bar there, it has to match up to what's going to that grounding electrode system.
Yeah, and I 100% agree with that.
Yeah.
And actually what's funny is some of these code changes are myths they're aligning with.
That's right.
Some of these code changes, they're fixing them as we're going with these myths, and we're going, okay, cool. Well, that's why we're doing the myth of the week, so that we can figure this out with a 2023. I think there's a lot of good things with 2023.
This is a good example. This type of change is for Jeremy Weed.
Yeah, I agree.
I'll just say this. This is another good example of exactly what I was trying to say.
Dude, don't be hating on Weed, man. Come on, man. Dude, Weed, man.
He deserves it right now.
All
right. Now, 250.102C1. Now, what they've done here is they made some changes to clarify where you have parallel conductor installations, of course, that are in 2 or more raceways. And they're just clarifying here that supply size bonding jumper, you have to install it in accordance with 1 or 2 below. Right. So number 1 didn't really change except for clarifying that it's an individual and then it's based on the size of the largest ungrounded supply conductors that's in each raceway or cable. But in 2, they did some, which I think is very important clarification here. They tell you if you have a single bonding jumper that is installed for those 2 or more raceways or cables, they're telling you it has to be installed in accordance with table 250.C1. And look at this, based on the sum of the circumferential areas of the largest ungrounded conductors from each set connected in parallel in each raceway or cable, and then the size of the grounded conductors in each raceway or cable should be based on the largest ungrounded conductor in each raceway or cable, or once again, the sum of the circumferential areas. That's a big change right there.
I like that one. That gets rid of all that crap they were doing with like a 600 MCM to like.
Sure it is.
The stupid things they do. They're like, that's true. And it's like, what really?
Yeah. And we did a substantial.
You're putting a 600 MCM bonding conductor. Like, really? Like 12.5%. Like, what?
Well, when you look at that the way they've got that set up, do you see any 12.5% on there?
It ain't there because that's change.
That's right. and I used to say, no, you don't do that for that. And they'd say, oh, you don't know what you're talking about. Well, now they've clarified it that what I was saying was correct on that.
Yeah, absolutely badass.
Now, in number 4, they're still in 250.104 here. Or I'm sorry, we're in 250.104. And this is where you're dealing with a separately derived system. And what we're going to be looking at specifically here is exception number 1. And what they're telling you here is that you have a separate bonding jumper to the metal water piping system. It shall not be required if the metal water piping system is used as the grounding electrode or grounding electrode conductor. Now, I find that very important because basically what they're doing, they're tying the two together right there. And
I like that.
And they're telling you this is for a separately derived system, and the connection to the water piping system is served in that area by the separately derived system. Now, that to me is very important because they're clarifying that it just isn't electrode. It's also considered based on that grounding electrode conductor.
So let me ask you this.
Mm-hmm.
Let's just say I have a transformer in an area. I have, let's just say it's a 3-aught or 1-aught, whatever. You can just make up a number. And it goes up the building steel. Now the inspector sees there's a water pipe going across there.
Mm-hmm.
Do you think it's a good idea for that to be bonded to the water pipe as well?
Sure.
That serves that area?
Yeah, you got to bond any water pipe in that area. And that's what this is getting into. See, the next one's going to get in the structural steel. They've made clarifications here. And that's what this is. It tells you here, metal water piping systems and structural metal that is connected to form a building frame shall be bonded to separate drive systems in accordance with blah, blah. So let's see what it says for a metal water piping system. The grounded conductor of each separate drive system shall be bonded to the nearest accessible point of the metal water piping system. End of discussion right there. Yep. It's in that area. You got to bond it the nearest accessible point. Okay.
I got it. All right. Cool. I like it.
And the same thing's going to happen here when we're dealing with structural metal. You're going to see they're going to be talking about the same thing, added pretty much the same language here, and just sort of clarifying how you can go about bonding that in.
I think where the confusion comes in with everybody is when you get into the exceptions, because that's where everyone's like, okay, so you have to do it for this, but then you don't have to do it because of the exception.
That's right. And they're clarifying that now.
Yeah.
All right.
I like it.
Now, the other one, 25109, talking about metal enclosures.
Dude, I love this one. I love this cover.
I do too. And that second sentence, it says, if installed, metal covers, plaster rings, extension rings, and metal fittings shall be attached to these metal enclosures to ensure what? An effective ground fault current path, or shall be connected with bonding jumpers or equipment grounding conductors, or both. And then it tells you to see for over 250 volts to ground, go to 250.97 to tie that in.
So what I really love about this one is the first sentence. Metal enclosures shall be permitted to be used to connect bonding jumpers or equipment grounding conductors or both, as long as they're connected to an equipment grounding conductor.
That's right.
So I like that the most because the whole thing is they never included a whole bunch of metal enclosures before.
That's right.
And so now they're saying that auxiliary gutters are not required or not permitted to be used as equipment ground if they're not listed. Well, this one right here doesn't really give you, like it.
That's right.
It doesn't really give you a thing saying, yeah, that's true, because where did that come from? I don't get it.
Basically,
because Willie Jackerson is making gutters in his basement doesn't give him permission to make unlisted gutters that are unlisted for grounding, but it's metal. And he says everything got 3 Ugga Duggas on all the bolts. You know what I mean? So, like he said all the bolts are tight, but it doesn't matter if it's a listed enclosure. To me, per NEC, it's listed for grounding and bonding.
That's right. And
we got a good one in here.
If you look at what the code panel has done through the years, basically what they've done, anything that's metallic has to be what? Grounded and bonded.
Yeah, I like this. We have somebody in here. Yeah, you know. So you cannot use the sprinkler pipe as anything. You can't use it as electrode.
No, it cannot be used as an electrode at all. But what they do, they go in and they bond that in. It's sort of like they do the gas pipe also, because that's where you're going to get over in 250.4D, and they're going to talk about other metal piping systems. So
Yeah,
you bond it in.
So water pipe would be cold water, I believe. I don't even think you use hot water.
Basically what it goes into, it just talks about metal piping systems being bonded in. It doesn't differentiate between any of them over in the bonding. If I go back over here, let me open this back up.
Yeah, and I agree with that. So he's saying water pipes under earth make sense for electrodes, does not require bonding jumper, but you know, like
Yeah.
there's
If you look at that, this is what I
underground.
was just talking about. When you're reading that there, does it say anything about cold water pipe? It just says metal water piping systems.
Right.
That's what I was saying. And where that cold water pipe he's getting into is when he's going over looking in 250.52A1, which doesn't have anything to do with 250.104.
Valid point. Valid point.
Okay.
Yeah, I mean,
did that help him out?
we ran into this before where we were doing a building and they wanted the gas pipe bonded. And this dude's like, hey, I think that's a code violation. I'm like, no, it's not, because they're not using it as an electrode.
Okay. He agreed. He said, true, James, true. Okay. So just wanted to clarify that because I knew where he was going with it, because I've actually had that question out in the when I've been teaching.
Dude,
before.
you got a true, James, true. That's your first true you ever got on this podcast ever.
That's okay.
No, I'm just kidding. I'm always busting on James. Like, dude, I was always salty since he stiffed me those 20 code changes back in 2020, man. I paid good money for a course. I expect all the code changes, and you're gonna just blame Colorado. Come on, dude. Come on, dude. You can't.
Don't put true, put stud. I'll stick.
There you go.
Oh, shit. Gotta enjoy it. All right, you ready for your tool review, brother?
All right, so you guys will love this, man. Do we got the video? Is the video gonna play?
I'm gonna.
All right.
No, I didn't get the video. I couldn't get it to link in.
All right.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right. Sorry for a really super lame tool of the week. The hook drill. So this is an attachment that attaches onto your drill. It basically turns your cordless drill into a drill press. This is featured for the awesomely low price of $99.99. It is surgically rust-proof stainless. I have not heard one good thing yet about this invention. They say that it's pricey. I don't know. I do like that it fits the ranch. I call my friggin' DeWalt cordless the ranch, so it fits the ranch. So if you guys got a ranch like mine, dude, that drill, the DeWalt drill in the top picture, that thing literally weighs like 10,000 pounds. It's like the heaviest drill ever made, but it fits the ranch. And like I say, this has been nothing but problems for tool groups. This guy, he invented this thing probably like 5 years ago, 6 years ago, and he just is so proud of it. He'll sell it to you for $9.99. It's got frothy welds. I hear a lot of these people out here that are watching, they'll know it's frothy welds. But the thing is, this is probably the worst product we will ever cover ever. So I wanted to set the bar nice and low. There's really nothing good about this product. It's wonky. It's it's wobbly. It doesn't really fit your drill right. The hose, it's like a hose clamp with like surgical steel on there, and you have to like adjust it to where you're gonna drill. He says it works good for like when you're up in the ceiling or whatever, but every time we see it, like I wish you guys, oh yeah, we got the Infinus tool in there. Once you guys see the video, you could go to Hook Drill on YouTube, and he's got a video on there. It's pretty wonky product. It's really weird. I don't get it. I guess he's got Hook Saw now too, so you could get the 2 combo maybe for $299.99 or what $199.99. I don't know what his price is. It's pretty expensive. I mean, everyone thinks that should be like $49.99 or $39.99 or whatever, but it's $99.99. So price wrong. Not a great tool. It's not even a tool. It's like a tool attachment. Like I've covered, backpacks before, but I mean, I could at least put that thing in a backpack, but I don't know. I think it gets our sorriest rating yet. 0 thumbs up, or it's 2 thumbs down. 2 thumbs down on the Hook Drill.
Oh God,
it's a piece of crap, and I wouldn't recommend anybody buy the Hook Drill. I give the dude props for his advertisement. I mean, he spammed our group really hard.
Yeah, I went over and looked at his website when I actually got that picture, and he had all kinds of tools that he attaches it to that he sells with the tool. I was like, oh, okay. I'd never seen that before.
Yeah, he's pretty. I don't know if you know this, but he's out of Texas.
Oh, is he?
No, yeah.
I didn't know.
I'm just kidding. Like I always gave you crap with the Texas boys. Like, dude, you gotta be the smartest dude in Texas. I'll start pulling all these dudes out, and I'll be like, "Hey, dude, this dude's Texas. This dude's Texas."
Like Jeremy said, he said we're all nothing but a bunch of glorified ditch diggers.
Yeah. Dude, I'll tell you what, dude. I cannot put anything past some of the guys. I mean, some of the guys over there at McKinney, Texas, even, I mean, they make themselves their own little reputation over there, so can't really say much. I know you're not far from McKinney, but maybe you're in the smart side of Texas.
I am. I'm in Fort Worth, brother.
Okay, all right.
I ain't over in the Dallas area.
all right. I wasn't saying nothing. I'm in a Mile High City. I'm hoisting the cup still. It's still elevated. I still got the cup up here. I'm still skating around.
It's sort of funny because, at one time they wanted to call us the Metroplex. I mean, you basically have Fort Worth, Arlington between it, and Dallas. And it's buildings all the way. Then you got Denton, and it's pretty much Dallas. It's completely full. Now they're going to Fort Worth, and it'll be full before too long. And it used to be, Dallas is busy. A bunch of traffic. I just hate going over. But in Fort Worth, it used to be hell. We just float around, take our time, But now we're starting to get a lot of traffic over here, and just thank God they're really increasing the lanes on the highways and stuff. But Fort Worth used to be, that's where Cowtown is, and I used to go out, wear a cowboy hat and boots. You don't see that much anymore over here like it used to be when I was growing up. And we're getting a lot of people and companies moving into the area. It's just, it's gotten very crowded here.
Yeah, we had Cali invade over here. Like we always say, like, don't California my Colorado, you know.
Mhm.
But like, dude, my hometown of Arvada, Colorado. I don't know if you heard it in my podcast, but it was like I went over there, dude. It's like downtown Denver now. Like all
Yeah.
the streets are closed off. Like, dude, they even have like a little putt course, so you can like bring your own ball and bring your own putter, and you could like do a little putt course.
Oh,
where
wow.
you used to drive down the street. You
Yeah.
know, like it's weird. Like, and I'm like, okay, so you know, like now we have like activities. You know,
Well,
like,
I will say one thing about Fort Worth. We got the Basses and Tandys and Dickies, and they got all kinds of money. And I'll say this: as big as Fort Worth downtown is now, it's probably one of the cleanest downtowns you'll ever walk through. They take care of Fort Worth, and they got a proposal now on the other side of Trinity River. They're looking at cutting in canals all over there. It's a big area that's over there, and it's called Panther Island in that area over there. And they're going to have river walking stuff all through there. Is what they're proposing.
nice.
Yeah.
Well, I want to give another shout out to Denver, Colorado, the cleanest city to have a Stanley Cup parade in. Yeah, that was so awesome, man. That was the greatest time of my life. I had so much fun down there. Parade. Joe Sakic hoisting the cup.
Hell yeah.
It was so fun.
That's why sports are so awesome. And
Dude, it was so fun. So fun.
all right. Well, let's wrap it up. We're at 1 hour and 53 minutes already. God, man, time went by fast tonight.
Yeah, I didn't drink enough of my eating cup.
There's a shout out for y'all eating. Did you hear that?
Don't be hating. Don't be hating.
Don't be hating, brother. All right. Well, everybody have a good week. We'll see y'all next week. Next week we'll have a senior on here. He's going to be covering Purge and Pressurized, which will be really awesome. And I think everybody will really enjoy listening to that. It'll be sort of like when he did the intrinsically safe and non-incentive circuits, a play on top of that. So I think that'll be really good. And him explaining, the next portion of the evolution of the hazardous locations.
Thanks for the love, all you guys, man. Awesome, dude. We love bringing you this podcast, and it's just as fun for us as it is for you guys, man. We really appreciate it. We appreciate all the listeners. Awesome. Awesome night, bro.
Hopefully next week we'll have a decision from the Standards Council. Waiting to see.
Oh, yeah. Can't wait.
Right. Everybody have a good week. We'll catch y'all next week.
Deuces. Thanks for everyone's participation tonight. Thanks to Bolt Online Academy. Thanks for bringing us. Thanks to NEC for Dummies. Knowledge is power. Learning today. Thanks to Teacher Saul Cup. Case Publication. Best publication on the planet. Thanks to Gray Boy. Thanks to Senior. Appreciate it, sir. Thanks to the 2023 Electrical Code Ninjas. The best Facebook group out there. The NEC Deathmatch, your only way to test your knowledge on code. Thanks to the Lady Apprentices. Really appreciate you gals. Really make us a great one. Thanks to YouTube and the High Voltage Live platform. Thanks to Electrical Code Discussion for awesome electricians. Thanks to Electricians Only 2, the second one. Appreciate you guys for joining us. Thanks to NFPA 70E Discussion Group and Electric Chamber Division. Thanks to Mark Candell, Estimating. Appreciate you, sir. Creative Solutions. Thanks to High Voltage Electrical Team. Appreciate you guys for joining us. Awesome. And I hope everyone enjoyed the podcast.